Happy Mother's Day, my little IOE scientists. Today we're going to do the volcano experiment. Now I have kind of an interesting way of doing this. Usually when you see volcano experiments in school or at home, people usually have this volcano shape already built, or they use paper mache and they create a volcano structure. I like to do my volcano experiments in the ground because I like to see what it's like to create pressure below the ground and maybe push the soil up and out of the way, which we're going to try and see if we can do that today. But at the very least, it just looks really cool because you have this reaction creating a liquid forming and foaming, and there's this reaction happening coming out of the ground. It looks a little bit more like a real volcano. So what I've done is I have created a hole here. Now, what I'm going to actually do is put a container down inside this hole, and I'm going to fill the container with the two most important ingredients for any scientist trying to recreate a volcano experiment at home, and that is baking soda and vinegar. These two chemicals are going to combine for a very interesting chemical reaction that creates a gas. Now, because it creates the gas, it is a chemical reaction. It's not a physical reaction. It's not a physical change, because when the vinegar and the baking soda combine, they're actually going to react and create a new molecule. The bonds inside the baking soda molecule are going to break apart, and they're going to create carbon dioxide. So if you look real close, you can see sodium bicarbonate. That means that there's two carbons that are together. They're going to react with the vinegar to create carbon dioxide, which is a gas. So that's going to flow up into the air. Now, if you contain a gas, any gas that's contained is going to create pressure. That pressure is going to build up and build up until it either stops the reaction or it can force its way through things. Now, volcanoes are interesting because there's three types of volcanoes in the world. And the main type that you're going to see pretty much everywhere, and people are familiar with volcanoes, is the cone volcano or the cinder cone volcano. Those are the most common volcanoes in the world, and those are the volcanoes people usually think of when they think of the word volcano. There are two other types of volcanoes. There's the composite volcano, which is basically a very large mountain, and they tend to form in areas where there's an ocean plate of the earth meeting a continental plate. What does that mean? It means that there's land plates that make up the surface of the earth. There's also the plates that are underneath the ocean, and where they meet, they like to move and bump into each other, and sometimes they create these really big mountain chains, but along the mountain is this weak point, and where that weak point is where lava is going to be able to come and push through. The last type of volcano is a shield volcano, and usually you're going to see those types of volcanoes on island chains that are formed by volcanoes, like Hawaii. Hawaii is probably where we're mostly going to be familiar with lots of types of volcanoes, and shield volcanoes are going to form when lava pushes its way through a small crack in the ground, and it creates sort of pool of lava. A lot of the times volcanoes, when they erupt, they actually don't create that much lava because the lava will cool before it reaches the bottom of the mountain or the cone. And it usually just makes the volcano bigger because the lava, as we know, is molten rock. It's liquid rock. It's rock that is so hot it is turned into a liquid. Not super unlike an ice cube melting into water, but obviously rocks need a much higher temperature to turn into a liquid compared to ice. So what happens is the lava flows down the mountain, it cools before it reaches anything because the air is much cooler. It's taking all the heat out of the liquid, and it forms more rock. With a shield volcano, the lava is going to kind of sit there and it's going to cool much slower. It's closer to the ground. With a composite volcano, that lava is actually not going to make it very far, and a lot of the times what happens is the pressure builds up so high with a composite volcano that it actually blows up and turns into this ashy, fiery cloud called a pyroclastic cloud, and that's really dangerous. When people need to watch out for volcanoes, if they know that there's a volcano that they live near, that's going to be more dangerous than the lava itself because it's going to go into the air. Now, for this experiment, I'm gonna put on two very important safety pieces of gear. The first being my handy dandy goggles, which is great because this is gonna protect my eyes. Now, when this reaction happens, like I said, it's gonna create pressure. So if the pressure gets too much, it could burst something into my eye, and I have to be careful. Let's check and see if I got these on right. All right, so we got that. And the other thing that I actually brought out today, people that research and study volcanoes have to wear a lot of protective gear. And I think this is a piece of protective gear we're all familiar with right now, which is the mask. Now, the mask is very important because aside from the fact that volcanoes can be very hot, when you're studying them, you have to wear protective gear that protects your skin. The biggest thing you need to actually protect against is the toxic fumes that are in the air. So whenever you're near a volcano, you have to remember it is, let me put my mask on here. Alrighty, we got my mask on. It is a lot of molten rock, again, which is the lava that we know when we think about volcanoes. When rocks melt like that, they give off a lot of toxic fumes into the air. Think about this, when you burn wood at a campfire, it's putting a lot of smoke into the air, and that's just wood. If you breathe in that smoke, it will make you very sick. You'll start to cough, you won't feel very good, you'll feel very lightheaded. Think about what would come out of a rock if you melted it and turn it into a liquid. There are little chemicals inside rocks that will turn into a very toxic fume that will flow up into the air. And if you breathe that in, that's not good at all for your lungs. So we gotta wear our mask. Let's check it out. Let's see if I got my goggles and mask on correctly. All right, so now what we're gonna do, we're gonna put this bottle down into the ground. And this bottle is gonna serve as our chamber, our lava chamber. Now, below the surface of the earth, I'm actually gonna keep this cap on so we can prevent dirt from getting inside that bottle for now. We don't wanna contaminate our reaction. We just want it to be baking soda and vinegar. So below the surface of the earth, really far down, 30 miles in some places, less in others, there's magma moving around. And magma is lava, it's just that it's lava that hasn't reached the surface of the earth yet. So it's moving around constantly, and when it gets too close to the surface of the earth, if there's a weak point, it's creating that pressure and it's trying to force its way through. So eventually it's gonna burst through the smallest or the weakest point in the earth, and it's gonna be able to create that big eruption, or it's just gonna kind of slowly ooze out like glue in a bottle that's leaking and create that shield volcano. So what we want to do here is kind of replicate a chamber that gets created. A chamber of lava that reaches the surface of the earth is going to create that pressure and cause that eruption. So what I'm going to do is I'm going to bury this bottle. I'm going to keep it upright like this, and then I'm going to fill this bottle with the two ingredients that I need, but not at the same time. So let's go ahead, let's put this here, and let's bury our bottle. Now, as I bury this, I'm gonna create that cool, classic volcano shape, just so it looks pretty special when I erupt this. What we can try to do is we can see if we can put something on top of this that the pressure will push out of the way and create a sort of mini eruption, but I'm not really sure it's gonna have enough pressure. You gotta remember, the pressure that gets created with a real volcano is quite powerful. It's building up sometimes for thousands of years before it finally erupts. Okay, so we've got our nice volcano shape here, and what I'm gonna do is I'm gonna very gently take off this cap, because I don't wanna let too many little pieces of soil fall in there, okay? Now, what I'm gonna do, I'm gonna put the baking soda first. The reason I'm gonna put the baking soda first is it's really tricky to get in, and we don't want to pour in the baking soda slowly after the vinegar is already in there, because that will cause the reaction to start immediately, and then it won't really create enough pressure and you won't really see a whole lot. So one thing that we can try is I can actually see if I can put this cap back on very gently and quickly after we start the reaction, and maybe the pressure will push off this cap. We're gonna try this a few times and see what works best. But I'm gonna put in the baking soda first. It's a solid, so it's gonna go in a lot slower, and it's gonna have to sit there for a second before I put the vinegar in, because I don't want to drop it in slowly. I want to do this all at once and close the bottle. I'm using my handy dandy funnel here to drop in the baking soda, so let's grab that. All right, now when I put in the baking soda, it's a little tricky because since the baking soda is a solid, I have to add it in kind of slow, and I have to make sure it actually makes it through that hole. So I have to kind of be patient here. A lot of things in science require a lot of patience. Okay, that should be a good amount. Let's get the rest of that in there. All right, let's see down inside this hole. Let's see if we can, ooh, that's pretty cool. Wow, nice, all right. I'm gonna put more in because you know what? I really want to create a really good reaction today. I want to make sure that this works really, really well, okay? And we see we got some clumps of baking soda, so you got to be careful about that because those will jam up your funnel. Let's see if we got enough in there yet. Nope, I want to add more. I want to fill this bottle with like half, I think that'll be really good. Put a lot in there. Let's put some more in. Forgive my poor camera work. I'm doing these things on my own. I wish I had a team with me here holding up sound mics and video cameras, but we gotta work with what we got sometimes when we're working out in the field as a scientist. Feel free to skip ahead through these parts. A lot of my good information was earlier on in the video, and if you're getting kind of antsy, you can always skip ahead to the part where I go to pour in the vinegar and close the bottle. All right, let's see here. Okay, we got a lot of baking soda in there. So what I'm gonna do now is I'm gonna try to pour the vinegar in and close this top really quickly. If we can get this cap to blow off, we might be able to do this again and put dirt over the cap. That might be kind of difficult to do, but we're gonna see what we can do. All right, let's see. Set my phone up right here. All right, so we got a nice view of this. Got a nice little view of the volcano. All right, here, let's try this. Let's see if this works. Okay, so let's see. We have the volcano here, so we still got our nice little hill. All right, let's get that focused. Perfect. Okay, so now let's throw in the vinegar and see what happens. It's gonna react really quick, so I have to be really quick. Woo! Hoo-hoo! It pushed the cap right out of my hands. I tried to get it in there, but it pushed it right out. Let's see. Let's see if we can add some more. Let's try again. Woo! All right. Look at that. Now this is pretty cool. So if we can imagine this is real lava, all this that pours out, first off, it's gonna go down the path of least resistance, which basically that just means it's gonna be pulled down by gravity, and it's gonna go down the sides of the volcano that's easiest for it to do. When it's done, it's actually gonna form, all the gas is gonna leave it, and it's gonna form into new rock. And you can actually kind of see that happening here, which is really interesting. You can see this is the original side of the volcano, and this is the new side that's been formed. So if we do this a couple times, this is gonna create more and more layers on the volcano. The volcano's just gonna get bigger. Another really cool thing is when this is done reacting, you can see all these little holes. It kind of looks like an English muffin almost. This is actually what a lot of volcanic rock looks like. And the reason for that is because as the volcanic rock cools, a lot of gas escapes the rock really, really quickly. So it forms these little holes in the rock. So this is really cool. This is a great way to do a volcano experiment at home and see a lot of really similar things to what actually happens in real life. Because when you build this chamber beneath the ground and you're working with real soil and real rocks, you can kind of see what happens when there's this gaseous reaction, chemical reaction happening along with soil, along with rock. So this has been pretty fun. I like this. I hope you've enjoyed. Let's give it one more little pour for the road here. All right, look at that. And I love how this lava is going in the same spot over and over again. It's trying to pour down that way. It's trying to pour down with this way. So if this is a real volcano, after a few thousand years of it erupting, it'll be bigger. All right, I hope you guys enjoyed this. I apologize for the shoddy camera work. I'm still working on this. As always, I miss you guys. I hope you stay safe and keep learning, keep enjoying your time together. Make this a good time experience. If you got little siblings at home, make sure they're doing their reading and you're taking care of them. Make sure you're doing all your work as much as you can, and I hope to see you guys soon. Take care.